video. So seems that some part that you already understand, which is about the backbone, right?
Yes.
We are sharing one cables. So if let's say at the main cable over here, they are breakdown. So let's say over here, because this one we are connected to the internet. So if let's say there are something broke here, so the entire network will be down also. So that the biggest disadvantages using the bus topology. So thank you. So I nak pick another person to explain. Haniful Khairi. Haniful Khairi, I want you to explain about star topology. Mana star topology ni? Okay. Haniful. Haniful.
Yes, doctor.
Okay. Can you share with us what do you understand on star topology and what the advantages using star topology? Why I should pick star topology and etc.
Star topology.
Yes.
For star topology, it's like easy to install, doctor. The advantages from the star topology.
Aduh,
And
dekat Nita ni. Okay.
that's that I know.
So basically, okay, thank you for the explanation. So
Okay,
I
doctor.
will just did some review and recap what we have learned throughout our module 02. So all together, because you're going to have your quiz, which is will be covered on module 1 and module 2. So our module 2 basically on theory also. But there are some part in calculations, right? This part. So we already learned on the Flynn taxonomy. So under Flynn wait. Okay, under Flynn taxonomy, we already look into four. I guess all of you already fully understand how to differentiate between all these four: SISD, SIMD, MISD, and MIMD. Easy, right? So over here, I already give you and share with you the diagram. So basically in the quiz, you are going to be like given the diagram, or maybe also, and then by giving the diagram, you need to pick what is the correct topology, what is the correct frame taxonomy, whether it is SISD or SIMD and so on. Or maybe sometimes you were given only the description, and you need to pick the correct diagram for it, something like that. So it is vice versa. I guess everything is easy, only that you need to still memorize that under MIMD there are two separate, which is two type, which is with share memory and also local memory. Only this is the different. The rest is similar. Only you need to understand the flow. Why it is single instruction, why it is a multiple instruction, why it is single data stream, and why it is a multiple data stream. So over here also, you already look into the flow of our computer system. It is very easy because you are not only looking this flow in our HPC subject. I guess From year one, you already look into basic flow of computer, which is you need to have input, you need to have output, and then there is a process, and another one is under storage. And all of that you already know about share memory processor, distribute share memory processor, and also multi computer. So over here, we had looked also on the share memory process multiprocessor and distribute share memory processor in our previous class. Still in the video, I also share it again. So already 2 times. I hope that you remember and already have full understand on that. And this one also we already cover in our previous class and in the video as well. So you can try to do it, and we only until this last week. So this week we supposed to look into on topology, what should have in the topology and etc. So I share you the class 01 video. So I guess it's very easy to understand. So over here we have several type of network topology. We have mesh, we have torus or ring. So either one, sometimes you maybe you can call it as torus, sometimes you can call it as a ring. Basically it's same. And then you have different kind of mesh, 2D mesh, 3D mesh, and etc. Same goes to the ring, and then bus, star. But mostly you're going to be asked only on the simplest topology, not going to touch on 2D, 3D, and etc. The basic like mesh, ring, bus, star, tree, cube, something like that. So in the video I already share also what and why, how the connection, how you going to look into this circle. I already mentioned this is not just a simple circle. This one have their own entity. Maybe these can be represented as a printer, can be represented as a router, hub, switch, computer, laptop, and so on. So there is also something like in star. You need to see this center circle. You cannot use like printer or a computer, but this central need to be only switch and hub. So sometimes they are term and condition, something like that. So that's why you need to know all in the topology, and it's very easy as long as you already go through it all. Like over here, you have a topology of bus. So bus topology in question, sometimes you only you only were given with the picture, and you need to know what is the topology. Sometimes you were given the topology, you need to find what is the advantages and disadvantages. So you have the advantage also because our quiz is only a multiple choice. So as long as you can something like okay, you remember 80% of it, so you can pick which one is the correct. So it's not too hard. And okay, I give you the example of star topology over here. You can see what I delete now. So over here you can see you have the central. You have this one a central. Sometimes it's not going to look exactly like this star. Sometimes you're not going to see it look like exactly like this, because it's the most important part is there is a central that connected all the devices, which is called as the central node, and it will be whether either hub or a switch. So I guess you already know what is hub, what is switch. And wait. Okay, so over here you can see star topology, also known as star network. So what is the advantages? What is the advantage? So under star, it's easy to install. If let's say you have any connection loss at one only, so it's easy for you to detect where is the fault, and it's easy also for you to just remove and insert any device. Let's say you want to add something between here, so you can just easily add. Or maybe you want to remove this PC or computer, you can just easily remove it without doing anything or setup in your network, and all other communications can communicate as normal. Okay, next is the disadvantages. Okay, I already. So you can see that under star, you need to have more cable because you want to connect every single devices to the central node. And if your hub, so your, let's say your central hub is breakdown, your entire network will also fail. And of course, as it require more wire, so it's going to be expensive. So we move to another topology. If let's say you did not understand, please stop me and ask me question directly. So let's say in this ring topology, you can see over here our ring topology. We have basically a connection like a circle. Sometimes it's not also circle. Maybe you have like this. This is all the nodes, a computer or printer, and you can have like a square or rectangle. As long as you can see that it's connected, uh, all the devices without any like go to somewhere else and so on. So it's called as a ring topology or torus, right? So over here also, if you can see, let's say you have the advantages is you can have the device access token, which is all the devices over here can have the opportunity to transmit. Of course lah, if over here I want to transmit, this is me, I want to transmit to somewhere it here, so I will send my informations or my messages or my data through all the nodes inside. So there is opportunity for all the hub to transfer or transmit the data from any other device, not only from yourself. And it is not required the central node, which is like a switch or hub, who need to manage your connections. Like a switch and hub, they need to manage your connection. And it is a point-to-point configurations, make it easy to identify and isolate fault. Let's say over here, I want to send my communication to here or here. I know that I cannot ping or I cannot communicate. So somewhere must be brought between my connection to this one. So it's easy for me to find the fault. But as it already connect throughout all the nodes in the network, so it very hard for me to change the location. Let's say over here, this is A and this is B. Let's say I want to move from A, I need to move to here, which is the place for C, let's say. So I move to here somewhere. So over here, from starting the beginning of the network, normally we already know where is the place. Let's say over here, okay, I know over here is A. This one is, let's say, F. Let's say over here is E. So I already know their own place. So if let's say something are moving or will or added in between, so my knowledge over here, let's say at B, I don't know where is exactly A now, because I just know A is here, but when it move, I don't know where is A. So I need to find one by one where is A. So it's hard for something that to add or to change the network, or sorry, not the network, to change the components or devices in the network. So as we are sharing, you can see we have only like one connection to all. So we are sharing the data because we will going to have only one connection to the internet. So if let's say we have 100 megabyte per second, so all, let's say we have over here six, we have six nodes, right? So we need to divide 100 with 6. What we have, 1, 6, 4. So it's about 40, 40 what? 6, 7, not 7, so 6. So about 16 megabytes byte per second per node. So one node only get 16 megabyte per second, something like that. So from you have 100 megabyte per second, so it's going to be reduce your bandwidth because you need to share, and there is a communication delay. Why you have the communication delay? Because you need to move from hub to hub, from nodes to nodes. So instead, if you compare to like the star topology, you have direct connection. You have direct connection. Let's say from A, I want to go to B, so I have direct connection. From A, let's say I want to go to C, I have my direct connections. From A, I want to go to D, I have my own direct connections. But over here in our ring topology, let's say from A, I want to go to B, I cannot have direct peer-to-peer connection. I need to move, which is I need to have the path or route, which is maybe it will be following the shorter path, or maybe our network already set up with their own paths, where I will be sending after this and this, something like that. So I need to send hub by hub, node by nodes until I receive or find my exact location, which is B. So this is the advantages, which is we have the delay. Sometimes it's very huge. It's depending on how far we want to send from node to node. So this is about the ring topology. And then we have mesh topology. Sometimes you're going to see it's quite hard to explain on match, or you are given with something like this, the picture, is it a mesh or not? So you need to know basically mesh is trying to having the computer and network interconnect to each other without having it's basically quite similar with a star, because star have all the interconnection to each other, you can see, but it is through the central node. So you have the interconnection to each other using a central node for star. But mesh, you didn't have a central node, but you have the interconnection using the cable. So you can see all the cable. So I give you the example that you can see. Let's say I have 4 over here. I have 4 nodes. It is printer or computer or laptop or whatever over here. So I have a normal ring connection. So this one is ring topology. But if I want to have match, I need to know that I have interconnection to all the computer or the devices. So what is the meaning? Which is this node can communicate to the right nodes, which is B. I write first the name, C, and then D. So A can have direct peer-to-peer communication with B. A can have direct communication to C. And if I need to have interconnected to all, which is one another, I can also have direct communication and connections with D. But now I still didn't have, so I will have by putting a connections wired over here. So I check B can communicate with A, B can communicate with D. But now it's not having a communication with C, so I put another one. So this mesh will use your, what is it? This equation, which is interconnection network, or you have the interconnection to all the devices in your network using this equation. So we already looked into this question last week. So over here, we will apply it in our mesh topology. So normally our mesh topology will use that equation, and because of that, it's going to be expensive because you need to have many wire. Going to have many wire, sometimes it's going to be long, sometimes it's going to be short, depending on how far your computer or devices are placed, right? So maybe your computer over here having distance of 100 meter, so you need to have a wire of 100 meter, so it's quite expensive, right? And so on. So over here, you can have also, let's say you have 1, 2, 3, 4, 5, 6. Okay, you have 6 nodes. You have A, B, C, D, E, and F. So first of all, of course, the very basic, you're going to have a ring connection. So you connect all together using a ring topology. And when you want to have a mesh topology, you can see that you need to connect all. So I start with A. I can communicate with B. I can communicate with F. But I still cannot communicate with C. So I need to draw something like this. So C is over here. I still cannot communicate with D. So I draw another line. I still cannot communicate direct with E. So I'm going to draw a line over here. This one is a wired. So I check now with B because I can see A have all the connection to each other. I will be over here. I have connection with A, I have connection with C, but I still didn't have connection with D. I still cannot have connection with E and F. And then I check my C. I still didn't have connection with E and also F. And I check D. I didn't have connection with F only. And lastly, my E, I didn't have connection. Okay, I have all the connection now, isn't it? So over here, you need to check like that. So when you have this kind of mesh topology, then you can say, okay, this is mesh topology. But sometimes you can see over here, you see over here, this node sometimes is still not connected with all, isn't it? Like this, let's say over here, this is A and this is B. So over here, you can see there is a ring connection inside here. And throughout over here, you can see out over here, it is a bus topology, right? So what you need to do is, as you combine it together, you can see over here at A, you cannot have direct connection to B, but maybe it is a far away from your network ring. This one is a ring, this one is a bus. Maybe you are having different block. Maybe this one is N28A and maybe this one is at N28. So it's far. It's very difficult for you to have direct connection between each other. So you are connected it to something or called a central node, but it is not a switch or a hub. So you connect to the device that connected to each other. This device can connect to the ring over here. And this one also, because it is a bus, so it connect to somewhere here. So you can see it's tried to connect or interlink to each other. Over here you can see that this node not going to have only one. Normally if you have ring topology, you have only two, which is right and left. But when you have something another connections, it's try to interconnect with other devices too. So it's already also known as mesh, but it is not a fully mesh. It is not a fully mesh like this. This is the fully mesh. But this one, as it try to have interconnect also to others, then it's called as a mesh, because you can see you cannot assume it as a ring, because if ring, you cannot have like interconnection to others. Same goes to the bus. So it is not a bus also. So it is combining between a ring and also a bus over here. So you can see that these nodes are trying to have the interconnect to others. So it called as a mesh topology. So what is the advantage and disadvantage? So of course you can see these advantages is very expensive. And the advantage is network can be easily expand. You can send data from one node to many. you can have the broadcast. So over here, you can broadcast to all devices inside the network. Same goes to here, you can do the broadcast, but you are passing through to this node, but after that, it will broadcast to others. So over here, it is if it efficient one node fell, let's say one node fell, so others will be not affected because you have others connections to communicate to each others. So tree topology, as in video also, in tree topology, you will see that normally in a big company, in a big organization, they are prefer to use tree topology. So why? And you need to have at least three. So 3 and 3. So this is the hint. If you want to have tree topology, you need to have at least 3 layer. 3 layer or 3 level. So 1 level, 2 level, 3 level, 1 layer, 2 layer, 3 layer of the hierarchy. So this one also you can see you have 1 layer, 2 layer, 3 layer. So on the first layer, normally I give you the example of our UTM network. Maybe you have a connection with your UTM network at your college or maybe at your faculty. So you have UTM. UTM network are handled by our CICT. And if you don't know what is CICT, you better go to find what is CICT, because normally UTM student know. If felt CICT lah ni punya pasal, something like that. So you have the main controller by CICT to the internet. So basically, if you look, you have normally using 192.168 point something network if you connect to UTM network. We as a UTM or CICT normally need to buy a public IP address. So to connect to the internet, we need to buy, and let's say we buy one public address. Maybe I just give you the example. Let's say 10.10.10.10. I forgot already. I need to check back. What is the standard form of IP address to buy? So in the world, they're going to have the standard, and if we buy this one, it's quite expensive, but in one address over here we can share up to about 6,000 user in one time, something like that. So if let's say we have more than 10,000, so we going to have, let's say, to buy at least 2 IP address, public IP address. So over here, let's say we have CICT, we connect to the internet. So all of us inside over here are going to use similar. This one is pay by UTM. So bukan UTM yang provide, but we pay it, we buy the address, IP address to connect to the internet. So one IP address normally it support up to 6 to 10,000 user per one time. So under CICT over here, we have the server. So server is at our first layer. This is the top layer, our first layer. and then you can see it's going to divide to several. Let's say we go to the KTHO college, and then maybe it's go to the KTC, another college, but also it's going to go to our school of computing, and maybe it's go to the school of electrical, right? And then maybe school of mechanical. So it will divide to several other server or router. So there is another router that will be sending. And then this router, it's going to go, let's say, dekat KTC. I tak ingat dia punya block number. I just name it as block A. And then there is block B. You can see how many block you have, right? So you have, this one is second layer. And then another block, you can see block A, block B, they have their own router also. So sometimes if let's say dekat block A ni, at your block A tak ada internet connection only. So block B ada, block C ada internet connection. So you need to know, then you know that your router having fault or maybe terbakar ke apa ke. So something like that. If let's say all network dekat block C, dekat block KTC ni, block A, block B, block C didn't have internet connection. So it's not going to be somewhere here. It's not the router fault at your block, on block, but your KTC block maybe. But you need to check also whether others, let's say School of Computing, KTHO, KP and so on, ada internet connection or not. If they didn't have, so the problem at our CICT. But if they have internet connection, your connection at your KTC router is wrong. So after that, conteng. So dari sini, let's say from our KTC, you have block A, block B and C, right? So contoh je lah. So this is the example. So from A over here, you dekat dalam tu, you connect, you dekat level 2, let's say kawan you dekat level 3, you connect. You can connect sometime with the Wi-Fi, right? You can connect also with the cable at your room. So it's depend, because router have several way for you to connect. You can connect to Wi-Fi, you can connect also through cable. You kalau dekat rumah you ada Unify, you go and look into your router. There is two router, kadang-kadang dia bentuk bulat macam ni, kadang-kadang dia bentuk segitiga yang ada antena ni. This one is router. Dia ada Wi-Fi, you tengok dekat belakang dia, there is several port. You kalau nak connect ke port tu dekat you punya PC terus pun boleh. This one is router, and you tengok you punya router ni dia connect lagi dekat salah satu, it's called a hub. Dekat hub ni ada at this hub dia ada apa ni, phone hub, phone kan, dia ada phone hub, dia ada internet hub. So you can boleh direct je connect ke situ, instead of you just using the Wi-Fi to connect to your Unify internet. So you kena tengok lah, because you selalu connect to the Unify. But what is basically Unify give you? Dia router ke, dia hub ke, you need to know. And for first time installation for Unity,
Unity pula. Unify. I tak boleh nak lukis lah tulisan I ni hodoh. Unify. Saya tak ada iPad nak conteng-conteng. So if let's say Unify, for first time install, janganlah bagi your punya parents yang biarkan orang tu install, the technician. Ataupun you biar je technician tu install, you tak tengok pun. So you as the computing student, you tengoklah apa yang diorang buat. Waktu di install tu, what they did, basically they are programming your router. Dia akan tanya dekat you, what your SSID name. Dia tak tanya SSID, what is SSID yang you nak. But basically dia akan tanya apa nama wifi yang you nak kan. Nanti you bagilah nama rumah you ke, nombor rumah you ke. That's why you sometimes you tengok macam-macam nama ada dekat kalau you open you punya wifi, then you try to connect to internet, right? So you tengoklah jiran-jiran you pun ada letak nama. It is SSID. Unify technician selalu tanya. And then they are asking you also password. Apa password yang you nak? So sepatutnya you as a computing network, you tengok dia punya device tu. Diorang connect daripada you punya computer, they're going to connect direct to your router first. This is how you going to configure your router. Dia macam-macam brand ada. Dia ada D-Link, dia ada apa lagi Cisco, macam-macam router company, brand. So kalau you guna D-Link ke, you guna Cisco ke, you tengoklah how the technician install. They going to direct connect you punya first router tu. Mula-mula dia mesti connect router dia dekat dia punya komputer ataupun dia bawa dia on device. So dari situ, they're going to feed or configure your router with the SSID, with the IP address, with the password and so on. So as a computer or a network engineer later on, you need to also do it. I do believe maybe also in several subject you also already learn how to configure your router kan, especially using packet tracer. So normally under packet tracer, if you are dealing with Cisco, you're going to play around with this, how you going to configure your router and etc. So that's why in our UTM, we have CICT. And then we will divide it into college, into faculty, and they have their own router also. So they need to configure for each of it. So after that, in all of that, it's going to connect to hub or switch. So dekat you punya level of block tu, mungkin block A ada level 1, level 2, level 3, they going to connect to hub. Ni block A, let's say block A. So block A ni dia ada satu router. So let's say this is your router. Dia is going to divide to several. And it's going to connect to switch or hub. Let's say this switch at your level 1. This switch to level 2. This switch to level 3. So switch ni, this switch are going to use cable. Switch and hub using cable, okay? So what if you use Wi-Fi, you direct connect to your router. That's why sometimes kalau you jauh, you far away from your router, you tak tahu pun letak mana. I pun kadang tak tahu kat mana diletak. So you cannot get your Wi-Fi connection. But your switch ada dekat several everything kat tu, dia tanam lah. You nampak dekat dalam bilik you, port tu je. So your port is connect to your switch. Your switch is connect to the router of your block A. Router block A is going to connect to your college. Let's say KTDI. So KTDI router, and KTDI router will connect to CICT. Something like that. So you have several layer, and the minimum layer will be 3. And you ni dekat bawah-bawah ni, you connect lah to all of the router, all the switch. So that is on tree topology. So normally in our big company, they're going to use tree topologies because it's easy to configure later on. It's manageable. And large network. Okay, for large network. Disadvantage-nya, if backbone line is break, the entire segment is down. As I already mentioned, kalau you punya KTC punya router rosak, so satu college lah tak ada internet. Something like that. So if let's say CICT, satu university lah tak ada. Something like that. So it's easy for you to understand and configure. But if let's say only at block A down, but the rest tak down, let's say block B, block C, ada internet, there is a internet connections, means that only the backbone of block A or only that rosak atau breakdown or fail. So entire block A only. So you can replace your router, or maybe you need to reconfigure the router. So it affect only the backbone line yang mana yang connectkan dekat situ. So more difficult to configure wired than other topology. So kalau nak configure, it's quite hard for only, let's say, because you need to have configuration at each level. This level CICT you configure. Kalau you configure this, you tak configure another level, so you dekat bawah-bawah ni, you tak boleh connect internet. So you need to configure this part, this part, this part. Each layer, they need to have their own configuration. So that is on the tree topology. So this one is how you going to calculate the nodes, the degree as mentioned in here, which is about your diameter, how many diameter, what is the description on diameter, by section, and so on. It is on this part. But it is not too important, which is this is just for you to have the knowledge on if using bus or star, how you going to measure your knots. A K plus 1. What is K later on? We will check it. Basically, it is an N also. N knots. And then the degree and so on. This one is just for your information on network properties. And then this one is issues on network. What is issues that normally happen? Like a latency. You need to calculate. And that is going to give you, but we're not going to cover on calculation under latency because we only cover in HPC, which is our high performance computing. We're going to look into our process. So this one is all the process, but we're not going to look into more on calculations like network bandwidth, network performance. We're not going to cover on calculations of all the performance. Later on, you're going to focus on programming. So you just need to know the information like message routing, the basics informations. So last part is I share with you on the informations about supercomputer. So you can click I give you the notes already. You can click over here and there is a link will be pop up. This is a link. You can see. Uh, and it will direct you and see what the history about computer, what is happening, the evolution of your computer. And we have the Beowulf project also. You can try to look into what is basically this one. As I already mentioned, this one is like more in history of computer, and you already learn in your COA subject also the evolvement of computer from 1978, I guess. I forgot about the exact date. Starting your microcomputer, I guess. What is the name? I forgot already. So you need to find out again what is basically happen on your computing evolutions. And maybe you can also check on the faster computer. So apa list what is the new computer yang top, maybe it's going to have speed not only 32 megabytes, so maybe it's more than that, maybe 100 byte, I don't know. So you can try to look into it. So that is on our module 2. So we already cover our module 1 and module 2 all together. So by I guess over here you already vote, and the rest from our chapter section 1 also already vote. So we can see that most of us are voting Tuesday 10 to 11 a.m. because I believe that you didn't have any class on Tuesday, right, morning. So we can have this quiz, and it is a multiple choice. It's not too hard. Only more on theory and your understanding only. So seems that we already come out with the time and also dates for our quiz. So it's going to happen on 13 April. So I hope that you can try to do some revision back on what we have learned. So any question for module 1 and module 2? Any question? So if there is no question, Syahmi, you belajar ke you punya Syak yang belajar? If there is no question, I hope that you try to do some revision back on module 1 and module 2. And if you, let's say you don't want to ask me directly here in our class, you can WhatsApp me. I will try to explain more if you want me to. So you can WhatsApp me anytime you want. And if you want to also ask me about your quiz and so on, I guess all information I already share, which is 20 question. If let's say there is any changes, I will inform in our WhatsApp group. And the duration is 1 hour. We're going to do it via our e-learning. And I think nothing much more on our quiz. I hope all of you going to get similar on section 1, which is I will put the benchmark is 8%. So you need to get at least 8% for your quiz. Kalau if let's say you didn't get at least 8%, you need to teach us. Tak kisahlah yang you nak teach apa, but it is on chapter 1 and chapter 2. Because you didn't ask me any question, I assume you have fully understand on what you have learned. So if you get less than 8% for your quiz, so you need to teach us something in our class. Is it okay? Angguk. Tak ada suara. Okay. So, I guess only until here for today. So, anything you can just WhatsApp me. I will re-upload our class sessions, also the video, and also the video from previous class. So, I will share in our e-learning. So, anyone still didn't scan the QR code, I'm going to share the screen now for the QR code. So for the rest, if you already scan, you can left the Gmeet session. Thank you all. Bye-bye.
Thank you, Radha.
Thank you, Doctor.
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 Thank you.
Bye,
Thank
Doctor.
you, Doctor.
Thank you.
Thank you,
Thank
Doctor.
you.
Thank you,
Thank
Doctor.
you, Doctor.
Thank you.